EV charging, one is that. The second is wireless charging. I'm looking forward to it, to be honest. I believe that that could be a possible game changer. There are technical constraints around it. The platforms which are currently available, the Qi charging, Qi as in the Chinese Qi, those have technical challenges around distances, dust, etc. But I think those are going to start changing the same way when we started off with a mobile phone. Of course, earlier it was wired, and now we also have wireless charging. But still, the standard wired AC charging may rule the roost for quite some time.
So very happy to see the fraternity here as always, and I hope you're all in good health and are keeping safe. Thank you very much for taking the time out today and joining during such a difficult time. It's such a big privilege and a pleasure to reconnect with everyone, our distinguished panelists who are handpicked because of the think input and the rich experience that they bring in. And thank you to our distinguished audience for joining us. We've received over 200 plus registrations, most of whom are CEOs, CXOs, senior leaders, many from the industry and across other industries joining in, our members and our repeat visitors to our webinars, so which is very encouraging and motivates us to provide even higher levels of dialogue through the online channels as well. And for those of you who are new with us today, the BlueCircle is an exclusive community and ecosystem which is curated for business leaders across 6 sectors, which are e-mobility, energy, real estate, healthcare, logistics, and aerospace and defense. We also present socioeconomic insights, which ultimately determine the evolving complexion of the market. Now, in response to the COVID challenge, the BlueCircle has also accentuated its digital presence. One of the many modes we employ is our weekly webinar series and our digital publication. And in addition to this, and you'll be happy to know that we very recently launched the first version of the BlueCircle app, which is curated for leaders. It is somewhat like the sector-specific LinkedIn for leaders that brings together the community together to have meaningful conversations, to connect with each other, and also house high quality curated content. Soon we will have exchange of business opportunities and other features being added to the app as well. So those leaders who are interested, please do join us. I will also share the link to the app in the chat section and soon send out invitations to our new guests post the webinar. We've also begun our selective outreach and have close to 3,000 leaders who've joined the waitlist for the community app as well. And today, as part of our innovation series, we're privileged to have big minds and leading thinkers of the industry to join in for the e-mobility community's discussion. The topic is innovation in e-mobility, battery and charging infrastructure. There is high awareness today about EVs, but still not the conversion expected. Some feel that the main components of the EV value chain have not evolved enough, and this lack of choice and certainty around options is keeping the customers away. Our leaders are here to discuss the viable technological innovations for e-mobility, the roadblocks they face, and the way forward. And now, in the best interest of time, I will just briefly mention the names and designations of the panelists here. We have with us Mr. Akhil Aryan, co-founder and CEO, Ion Energy. Dr. Akshay Singhal, founder and CEO, Log9 Materials. Mr. Maxson Lewis, Managing Director, Magenta Group. And the chair and moderator for this session is Mr. Pavan Choudary, who's also a board member and investor in BlueCircle, Chairman, Medical Technology Association of India, CEO of French MNC Wygon, is a public intellectual, best-selling author, and is a leading thinker in energy, e-mobility, and across sectors. So thank you very much for joining in today. I now request Mr. Choudary to please chair and moderate the session, sir.
Thank you, Siddharth. And it's a great pleasure to have as my fellow panelists such informed and articulate people. It is also an equal pleasure to see that such a high number of attendees have joined to listen to them. And their quality is reflected in the that we are getting. We will work on a first come first basis, as first serve basis. So we will be able to take in only a few of those questions, but Other questions will be answered on the BlueCircle app, and this dialogue can continue there. So coming to the topic, innovations in e-mobility, battery and charging infrastructure. Let's start with the battery piece and the motherhood sector of batteries, which is energy storage devices. There are different types of energy storage technologies: electrical, chemical, mechanical, thermal, and one more, which I'm going to come to. But among these four, we have a wide range of technologies, starting from superconducting magnets to methanol, to pumped hydro, to latent heat. Electrical, chemical, mechanical, and thermal have these some representatives from each of these sectors I mentioned. Then we come to the next ESS technology, which is electrochemical technology, where you have batteries and hybrid supercapacitors. Within batteries, you have the classic batteries and the flow batteries, but let me not go so deep yet. Let me, in a moment, pass on the baton to Akshay, who will help you understand this electrochemical piece or review it. And within this electrochemical piece, there is a star of science, which is the lithium ion battery. 3 scientists who discovered it have already got the Nobel Prize. And perhaps the focus might go a little more on that, depending on the questions also. All these battery technologies, we will try to assess on these metrics: technological maturity, efficiency, lifetime in years, charge time, and environmental impact. So this is the first leg of this discussion. And here I invite Akshay now to tell us more about this space, Akshay, so that we know which are the areas or subsectors of this electromechanical technology, and then focus on batteries, and then go to the innovation piece. Akshay.
Yeah, thanks, Pavan. Thanks for having me here in this discussion. It's a pleasure to be among such panelists, as well as a lot of participants have joined it. So it's really good to know. And so basically talking about batteries, although I've put together 2 slides very quickly for everybody's reference, I'll request the host to kind of allow screen share here. But just getting into the overall segment itself. So when we talk about electrochemical energy storage, we can look at this segment as into 2 categories, very broad 2 categories, which is something that you can charge and discharge, and something which you can refuel. And yes, refueling is also a possibility in the electrochemical energy storage when you talk about it. And that's where one thing that we need to understand is a lot of times we or at least it's a public, so to say, perception that fuel cells are a completely different category of storage systems, but they are also electrochemical in nature. The only difference is that fuel cells can be refueled, whereas technologies which include your lithium ion, supercapacitors, and other kind of electrochemical storage, they all can be charged and discharged. So that's the way, that's the basic kind of classification. So that I will need your help to kind of enable screen sharing here.
Yeah, sure.
Yeah, thanks. So basically, if you see on the screen, so first of all, let me explain what this chart says. So we have here energy, basically total energy that can be stored in the system on the y-axis, and then we have power that can be delivered on the x-axis. And when we talk about electrochemical storage, it is very important to understand the difference between energy and power, right? So what happens is that when we talk about energy, that is basically the total amount of energy that is stored inside a system. And then when we talk about power density or a specific power, we're talking about how quickly can we withdraw, or how quickly can we put energy inside the system. So the fastness of withdrawal or fastness of addition of energy is the power density of a system. and the total amount that is stored is the energy density of the system. And in that sense, different options that are available today here, which range from your capacitors to supercapacitors, batteries, and fuel cells, fall at different areas in this matrix. And hence, there also a question which has come to us before this panel was started, right? Which is about which technology will be the winner in the future. And that is a very narrow approach of thought process in that sense, because not every application has same kind of requirements. So different applications have different requirements, and hence different technologies are required, which can provide you the right mix of energy density, power density, cycle life, environmental impact, and all of those different kinds of parameters which are important to look at it from a holistic perspective. Now, as I was mentioning, there are two segments in which we can classify this. One is refueling based, wherein we have fuel cells, and then we have charge discharge based, wherein we have all these batteries, supercapacitors, and those kind of technologies. Now, another thing is to describe basically what different types of batteries we have seen so far in the world. So we started the most common battery, or the oldest battery technology that we use till today, is lead acid battery. So I mentioned here that you can see where it falls in terms. So it is very low on energy, very low on power in that sense, but it is very, very cost effective. Then we have the lithium ion, which is also very mature technology, and it is slightly higher in the energy density side and also has a better power density. And then we have other technologies, for example, which are being talked about, such as redox flow batteries. And the key difference between the other battery technologies and redox flow is that instead of storing charge in the electrodes, in redox flow, we store charge in the electrolyte. So that's the key difference between redox flow and other batteries. And the benefit is that because the charge is stored in the electrolyte, you can always withdraw the electrolyte and then transport it in a tanker. And that is a very important benefit of redox flow. And that's why it has been used in various places for grid level energy storage. And then we come across this entire segment of high power battery packs and high power battery technologies, which is basically an amalgamation of your lithium ion or lead acid tech with your supercapacitor technologies. And that can happen at a cell level as well as it can happen at a pack level. So this is the broader spectrum of different battery technologies where they stand today. Now, another thing I want to touch upon over here was that how do these different classes of technologies which are relevant for electric mobility compare in terms of safety, maturity, cost, cycle life, which is basically the total life of the batteries, energy, the density, and the time it takes to charge them. So if you look at it, the lithium-ion technology, which is obviously the most mature technology today, has a pretty decent energy density in that sense. And hence it works for a lot of applications, including your intracity vehicles, passenger cars, and stuff like that. Cost parity is very, very good in that sense on a per kilometer cost basis. And then safety is moderate, cycle lives are moderate, and charging time is moderate. But if you look, go ahead on the other side, which is fuel cells. So I've taken here two options here, which is basically the blue one is your hydrogen fuel cells, and the green one is what we are building at Log9, which is the aluminum fuel cell. So if you look at fuel cells, one of the major benefit that you get is the charge time is significantly reduced because you don't need to charge them practically. You can refuel them. So hence you can very quickly, you can go back on the road by just refueling hydrogen or aluminum in the system. At the same time, energy density is very good. It's actually quite better as compared to your lithium ion. So you can go for long ranges. Now coming to the third segment, which is your high power battery technologies, which is also being built up in the world. And Log9 is also working significantly on this high power tech. You look at this technology brings benefits completely on the other segment, which is very high life of the battery pack, very high safety levels, extremely safe battery packs, no risk of fire, explosion, or anything like that, and very quick charging times again. So because all of these 3-4 different categories of energy storage systems have very different parameters, therefore they find usage in specific niche applications. For example, we believe at Log9 that the high power technologies are very relevant for the intracity short haul commute, whereas lithium ion works very well in the mid segment of personal use case vehicles and mid-range vehicles. And then fuel cells will work very well for long range vehicles. So that is the broad classification that we can look at. Yeah, that's all from my side, Pavan.
Okay, excellent. Actually, when you put up these slides, Akshay, I went back to my physics and chemistry classes, and I thought that here comes an intimidating slide, but it was so clear and it was so additive. The battery part, which you have spoken about, despite deep research from BlueCircle, added new points. And I will ask Siddharth if he can borrow these slides from you, then he can put it up on the BlueCircle app, and hundreds of people will learn from this, or at least enjoy seeing it from another lens. And the other point which you said was charge time is important, discharge time is also important. And the third thing which you said was innovative technology, which is the most innovative or which will be the most successful technology. This question is too broad to be accurately answered. It has to be defined for which use case you are talking about, and then there will be different answers for different use cases. Great points, Akshay. Coming to Akhil. Akhil, you are at the cutting edge of battery management using data analytics, artificial intelligence, etc. Where do you think this, where do you think the train has arrived, and what are the innovations which are likely in this sector? Akhil.
Hey guys, thank you so much, Mr. Choudary, and hello everybody. Thanks for taking the time today. So building on top of what Akshay shared, I'll just set some context before I start talking to you about the innovations in the space. I'm sure most people on the call are aware, but when it comes to batteries, it all starts at the cell. Once you have a cell, you essentially put those cells into modules. Those modules typically make their way into a pack, and then packs typically go inside of systems, right? So that's sort of the sequence. When you start building battery modules or battery packs, you need a layer of management for those batteries so that you can not only tap into the data that we are logging at every single cell, but also build a layer of safety at that pack level in a way that when these batteries are charging or discharging, there are no fatal incidents that happen, right? And so that's essentially the layer that we typically call battery management, simply put, very good name. And for this purpose, there's essentially an advanced electronics controller that is introduced inside of a battery pack, which is called a battery management system. So that's essentially what a BMS is, right? So that's the first layer of context. So far, the history of the BMS really starts with something called a PCM, or a protection circuit module, which essentially just took care of safety. And so this was when we were building power banks and mobile phones and small battery packs of 100 grams and 200 grams, where you wanted to make sure that in the case that something bad happens, you want something like a fuse, right? Just like you have a fuse that will sort of disconnect and prevent the battery from exploding or any harmful situation. Now, as we went from hundreds of grams to hundreds of kgs, right? Clearly, you need better technology, and you need more layers of safety because the risk levels also increase. And so naturally, the electronics have shifted from PCMs to what we call today BMSs. The big difference between PCMs, which are protection circuits, and battery management systems is the fact that battery management systems typically have a microcontroller, which means that they're not just a dumb fuse, so to say, but they also have a brain. And what does the brain allow them to do? It allows the electronics to do things like estimate the current state of charge of the battery, estimate the current state of health, and so on, state of power as well. So what does that mean? What does state of charge, state of health mean? Whenever you put your phone on charging, your laptop on charging, you see a certain percentage, right? 10% left, 20% left, 30% left in your battery. That is essentially the output of a battery management system that exists inside of your phone or your laptop. So what it's doing is that it's taking the raw current, voltage, temperature, converting that into a state of charge, which is basically giving you a percentage. Now, if you can imagine, sometimes on your phone, let's say, even if you buy an iPhone, you might buy it and then 2 years later, it might show you 75% and suddenly drop down to 65% or 68%, right? Nobody likes that. On your phone or your laptop, it's not a big deal. You know, you can just put it on charging and that's fine. So you're not happy about it, but it's not a big problem. But when you move into bigger batteries, like say electric vehicles, right? So imagine you're driving your car and it says that you can go 25 kilometers and you say, okay, that means I can drive until home. So no problem, you're driving. And suddenly halfway it tells you, hey, by the way, actually I was wrong. So you just have 5 kilometers left, right? And you know, now you have to sort of stop on the side and find one of Maxson's chargers and figure out how you're going to charge this vehicle, right? Which is why it's extremely important that you have a highly accurate state of charge, state of health estimator algorithm that is running inside of big batteries that are going inside of electric vehicles. And so that's essentially the start of you know, what we've been doing at Ion and also the product that we've been sort of selling in the market. So we've been fortunate, like in the last 4.5 years, we now have over 70,000 vehicles on Indian roads that are using our BMS. And we've collected a tremendous amount of data to help not only collect primary state estimation, but also use the data with opportunistic recalibration algorithms to continuously improve the accuracy on Indian roads, right? India is very different from Germany, for example, or the US when you want to do, you know, state estimation or range estimation. Again, similar to once you understand the state of the battery, only then you can say how many kilometers can you drive, right? So that is the conversion of state of charge into distance to empty, right? So how much distance can you travel before it is empty? So all of these estimations have to happen in a highly accurate way. And these are typically the responsibilities of a battery management system. We've been fortunate, like I said, to be able to collect the data and improve the accuracy of this over time. But there is a layer above that, which is not just at the local battery management, but how can we bring the data from these vehicles to the cloud and then leverage the data not only from one vehicle, but from the entire class, the entire set of vehicles, and try and improve at the core, at the fundamental level, the state estimation algorithms, and also run co-optimization algorithms. For example, if you are owning and operating a fleet, imagine you're an Ola or an Uber, and you want to collect the data from all of these vehicles and come up with an algorithm to say, how can I manage my charging speed and my charger locations to ensure the highest fleet uptime during peak requirements, right? So these are the types of challenges that you can solve using software if you have that connectivity. So I'll pause here, but I just wanted to set the context of how battery management plays an important role in the transition to an all-electric future, and also how software brings it all together for continuous improvements moving forward.
Beautiful and lovely analogies. So the PCM came for, which was the first, let me say, avatar of battery management system, was for safety. It was a dumb fuse. Now this microcontroller, which is there, it is not a dumb fuse. It is, as you said earlier, it's like a muscle, and it is living in the battery, and the brain is there in the cloud, which you last spoke of. So beautiful. And you have said that battery management system is no longer only for safety, but also for efficiency, health, quality, and longevity of the battery. Great points, Akhil, and beautifully made. Let me now come to Maxson. Maxson, as you know, is a leading figure in the field of charging infrastructure. Is a leading protagonist there with Magenta. So the first point I would like to ask you, Maxson, which also comes from one of our questions by Nitin Choudary, CEO of Quantum Leap Consultants. Dharmil Shah, Director of DPS Bearings. What is the procedure for setting up a charging station? And what are the outlays, investments, and revenues typically associated with the charging station? Maxson.
First of all, Yeah, first of all, thank you, BlueCircle, for putting this great set together, and also my fellow panelists for having built it up very nicely. You know, first we start with the material, then the taking the form and shape of a battery with a software to go with it, and then it comes to us to say how we can charge this entire ecosystem and make sure that the next time you have an electric vehicle, you are not short of power. So that's what we do. And before I answer the question, Dr. Pavan, I just want to kind of, if at the cost of saying oversimplify this concept of EV charging, and then I think it would be very important for people to understand it. And that is where I'd request access to just share one slide. Siddharth, if with your permission, can I share a slide, please?
Absolutely.
Because demystifying EV charging is very important before we get down to how the complexity. So if I were to classify EV charging, very simply, it's conductive, wireless, and battery swapping. These are the options currently in place. And more often than not, it is conductive charging and swapping. These are the two elements that the world is looking forward to. And when I say conductive charging, there's a wire from the charger to the vehicle. And there the charger is either the AC-DC converter is inside the vehicle, which is onboard charging. If it is outside, it's an off-board charging, which is also called as DC charging. Having understood this snapshot, it's important to what exactly are we talking about when we talk about charging largely is the conductive charging, and within conductive charging, the AC and DC charging, which kind of is at this point driving the EV ecosystem. And now comes to the challenge. The challenge comes on the fact that the batteries that come along with the vehicle, and Akshay and Akhil help put together, I mean, these are huge storage houses of energy. And unlike a petrol and diesel filling, where the per liter capacity of storage or transfer of energy from the fuel station to the vehicle is pretty fast. It's around 3.5 minutes on an average. But here in EV charging, it's huge amount of power, which has to be safely dispensed into the batteries. And that's why it is important to understand it is not only about having a location and electricity, it's about the entire ecosystem, where it also includes the time that the vehicle is stopping by to charge. Now, having demystified all these elements, I'll try to answer the question of what are the challenges, what does it take, and then what are the challenges. Simply speaking, as per the notification by the Government of India, Ministry of Power, 18th November 2018, for anyone to get into the business of EV charging, sale of electricity is no longer notified for electric vehicle charging. It has been denotified, which means you don't need a license, unlike if you were to sell power at your homes. So till such time you have a qualified EVSE, electric vehicle supply equipment or a charger, you can actually set it up and sell or make a business value out of selling energy or through charging. It's as simple as that. So Government of India has, in fact, many people miss this, is one of the most important date in the history of EV ecosystem is that the day when it got delicensed. Now, once you need to set it up, essentially it's the space is the charger and your decision to either go with an AC or a DC charger. And then the more critical and the more important part is the backend infrastructure, which is one is the power, ensuring that you have 100% uptime on your power. Second is the tech part of it. And I will absolutely agree with Akhil on the fact that EVs essentially are the top-end mobile phones, except that it has 4 wheels and a steering wheel. Otherwise, it's the same thing. It has a BMS, it has a software, it has a display. It's almost the same thing. It just, and when you're talking about this high-tech vehicle with you, the ability to ensure that charging and all the ecosystems start to have the tech angle, that's when the entire ecosystem really falls in place, which also means that individuals to man the charging stations, etc., are moved out. All of it happens through the app. And that's what we're doing at Magenta, is ensuring that these, and Akhil, I'm going to borrow on your statement of you cannot copy paste international solutions to India, especially in EV charging for 4 reasons: heat, humidity, harmonics, and humans, each being very unique, right? And hence we believe that you have to make solutions specific for India. And that's what Magenta is trying to do is, let's say for fast charging, there's a different solution. For at your offices, it's a different solution. At homes, it's a very different system. Homes, you will not be using fast charging. You'll typically use AC charging. for malls, etc., for highways. So these are the various spectrum of solutions that need to be developed, and there's space, a lot of space for everyone to join the entire EV ecosystem, especially in the charging space.
And the charging investment in a charging station and the likely revenues, what are the ballpark figures?
Sure. In fact, I'll give you the exact figures, to be honest. I'll move around the cost of real estate outside of the realm of this discussion, because it varies across cities. It varies across whether you are inside a basement or, but if you have to leave that, the cost of a AC charger, only the charger approximately for public charging, you should qualify at around 50 to 60,000 rupees. I'm talking about the base charger. And for a DC charger, depending upon the voltages, it moves anywhere from 3 lakh rupees to 8 lakh rupees, depending on how it goes. But one thing which everyone misses is the fact that it is not the cost of the charger, which is the biggest part of the game. It's the part of the backend infrastructure, including if you don't have the sanction load, setting up a transformer and the entire wiring. In most cases, on an average, I'm just giving some thumb rules, it is the cost of the infrastructure is 1.5 to 3 times the cost of the charger. Right? So this gives you some very high-level ballpark figures to build the business model around EV charging. Hope I've answered the question.
Absolutely. Absolutely. Beautifully. That means it makes more economic sense to get the back-end infrastructure in a place where you can have multiple charging stations of your own.
Absolutely. In fact, there was one point, and I think I had a very interesting discussion earlier, is the fact that while at this point we're talking about single charges at multiple locations, it's essentially to reduce the charging, anxiety. But the tomorrow belongs to micro charging hubs and then macro charging hubs, which need to be built up. And that is where the efficiency of the system lies.
Great. Super points. Now, and it was harmonics, humidity, heat, and one more edge. I would go for harmonics because this entire panel discussion is becoming harmonic, and I really love it. So, and before I go to Akshay, I find some harmony between what you have said and what Akhil also said at an earlier occasion, that the electronics is eating up the car, you know. So it's not only electronics, but software also operating through electronics, which is eating up the car and is more and more becoming like a device. Great points. Coming to Akshay. Now, Akshay, within the battery technologies, which have a strong maturity base, they are technologically mature. Which are the ones which you feel, including lithium, which have the best chance in which specific sectors? Can you speak a little more about this? And that will also help us understand what are the viable technological innovations in this space, which is our promise to the audience in the title and the talk track.
So let me, absolutely, Pavan, it's a very valid question. And let me start by talking about what are the requirements of the different platforms that we have in the ecosystem, right? So if you look at the entire spectrum of electric mobility, starting from your two-wheeler, three-wheeler kind of vehicles, and all the way up to buses and trucks, which go between cities for long distances, different platforms have very different, so to say, requirements when it comes to the battery pack, like the kind of power draw they want, the kind of life they want, the kind of sort of the performance and range that is required. So if you look at the two-wheeler, three-wheeler segment, which is primarily the intra-city segment, and if you look at that segment, these vehicles hardly leave the city limits. So range is not that big of a concern in these vehicles. But what is a challenge in these vehicles as of today with the lithium-ion battery pack that are going there is the amount of time it takes to charge these vehicles, the overall performance of the pack in the vehicle, and at the same time, the life of the battery. Especially when you are trying to use these vehicles for commercial applications, where we believe the adoption of electric mobility will be far higher as compared to your personal use case vehicles. So from that perspective, these are the challenges on the two-wheeler, three-wheeler, intra-city side of things. But when you move to the other end of the spectrum, which is your long-haul mobility, over there, range becomes one of the most critical factor. And what typically happens is that when you try to kind of match up that range or increase the range by increasing the battery size, it becomes an unviable solution. I'll give you a very interesting analogy here. So if you consider a typical electric four-wheeler LCV, like a Tata Ace kind of an equivalent, and even Mahindra, for example, came out with a platform which is not discontinued, but Mahindra Supro electric four-wheeler LCV, that vehicle had 100 kilometers of range with a battery weight of 150 kgs. But for long haul mobility, you need at least 500 to 600 kilometers of range, if not more. And moment you kind of try to achieve 500, 600 kilometers of range, the weight of the battery pack starts to become close to 1 ton on this vehicle, which is the total load bearing capacity of the vehicle itself. So either you can carry the battery or you can carry the load on the vehicle. And that becomes a very big unviability issue. So ballpark, what I'm trying to say is that different platforms have very different requirements or asks from the battery pack. And hence, what we can look at from this perspective, that in the intracity scenario, you require something which has very high life, which can be charged very, very quickly. At the same time, can give you very high performance with a small battery size. Whereas on the long haul, you need something which can, in the small size, give you a very long range. So that is the kind of requirement. So in that perspective, what I believe is, while lithium ion battery as it exists today and the various chemistry that there are very good for the mid segment, and they stretch across the other two segments as well. But it works very well in the mid segment, wherein we're talking about personal use case vehicles, passenger vehicles, four-wheelers, cars, and stuff like that. The short haul mobility will go to high power technologies. For example, your hybrid supercapacitors and hybrid battery packs, which can deliver much high power and give you very long life. And at the same time, the long haul will go to technologies which are particularly in the segment of fuel cells, because fuel cells can provide you much higher range on the same system weight. Now, coming to your last question on maturity, so in that sense, fuel cells, particularly hydrogen fuel cell, is a mature technology, but the challenge really is of the cost on that front, and hence other technologies, like for example, we're developing aluminum fuel cell, which will be cost effective, but it will take some time to get to the market. On the other side, when you talk about high power battery technologies, that is something which is already in a maturity, very, very high maturity level. And it is already being rolled out in the market by us and by other companies around the globe as well. So that is the overall play of maturity. Obviously, lithium ion in the basic chemistry like LFP and NMC are the most mature in the segment. That's why you see almost all vehicles today running on these technologies. But eventually, different pockets will emerge and different technologies will win in individual pockets. In that sense.
Great point. So if lithium ion is just one of the technologies, what is the reason that 90% of the investments are still going in lithium ion? Is it because of the short-term nature of the contracts? If the contract will be 3 or 5 year old, naturally it will be pushed through lithium ion, which is an existingly already stabilized technology. Or is there some other reason? Because lithium is somewhere straining the material resources, the environmental impact is high. So why is lithium still the king? And the other technologies have not risen as fast or as surely. Another question which comes up is that silicon for solar cells was one of the many materials which were being tried, and it was successful in making a solar PV cell. And there were so many companies which came with alternative materials, but they could not actually challenge silicon. And they came because silicon prices were going up, because it was being used not only in electronics, but in solar cells also now. And eventually, most of those companies capsized, and silicon still rules the solar market. Do you feel that lithium has something which may justify a similar long reign buy it in the in the battery market, or you feel that there are some chinks in the armor of lithium? Akshay.
So basically, what has happened is that if you look at the global electric mobility scenario, platforms which have been most widely adopted or scaled up at a large level are platforms where lithium actually really works, right? So in the normal lithium-ion technologies really work for those platforms, which, as I mentioned, four-wheeler, passenger cars, personal use case vehicles, and stuff like that. And that has been the market which has scaled up so far outside India, and hence there has been a great push behind lithium in that sense. At the same time, I would like to also mention that when I talk about high power battery technologies, it does involve lithium. It is an supplement of, I guess, a supplementary technology to the current lithium ion technology to make it more viable in that segment. But when I talk about long haul mobility, lithium completely derails the entire viability and the cost issue because as I mentioned, weight is too high, the cost becomes too high because when you're trying to increase the larger pack size. So in that sense, it will kind of, as I said, there will be pockets and there will be specific technologies that will be relevant to those pockets. Coming to the second part of your question, which is about why, for example, the example that you took of silicon in PV cells, there other technologies or other materials which are coming up in PV cells were only trying to win one argument, which was cost, making it more cost effective or just increase life. But here are other operational parameters which also need to be thought about. And that's why these supplementary or complementary technologies will be very important in the future.
Excellent. And long time back, no one believed that solar cells will become so cheap, but they did. And similarly, hydrogen may become also economical in the times to go. Lithium itself has dropped by 85% in the last decade, the prices of lithium. So great points. Basically, what you're saying is it's hybrid supercapacitors for low range, lithium for middle range, and hydrogen or fuel cells for longer range. Great point. This is a very good prism to look at viable technologies through. Akhil, how would you like to build this? And what is it that you would like to add from battery management perspective, as well as from any other angle which you'd like to bring in? Akhil.
Yeah, I think Akshay painted a really good picture. And incidentally, people think that there's sort of a winner takes all opportunity everywhere, and that's sort of which even Maxson brought up a beautiful point, and he said, look, there's a lot of room for a lot of players, and as entrepreneurs, and I'm sure there are many other entrepreneurs in the audience as well. If you're pitching to investors, you like, how are you different from the others? What if others enter? And the reality is that there's a lot of room. It's not a takes all market. We're literally all together, and Mr. Choudary, we spoke about this before. All of the things that we're speaking of are sort of a subsection of a much larger foundational shift that's happening in the new energy transition, which is that, sure, we're making smarter batteries, better chemistries, we're creating a better infrastructure to adopt electric mobility. But if we have to get to an all-electric future, which is carbon neutral, there's a fundamental shift that needs to happen across the board, right from energy generation, distribution, storage, and consumption across the entire value chain. And we're playing a part there. And I'm sure many other people in the audience are also playing their parts in this journey. So I think it's important to acknowledge and appreciate the joint effort that we're making as a community. But coming to specifically the point around which chemistries might work out in the future, and also the role of electronics and software. One of the things that fortunately I can say for Maxson as well as for myself, and of course Maxson can speak for himself on this point, but I believe that we are slightly hedged in our position when it comes to technology, which is sort of it's a lower risk bet from a company standpoint. But of course, everyone knows risk and return. So, next thing you know, Akshay is a billionaire. We are just selling electricity here and there. So essentially, what I'm trying to say is that when it comes to electronics, software, infrastructure, the benefit is that it is at arm's length from the core technology that eventually becomes successful. But I can vouch for what Akshay said, that in reality, it's not going to be one or the other. It's going to be a hybrid. But I should also highlight that it's not a hybrid of everything. It's a hybrid of a few things, right? So whether it's going to be lithium ion and hydrogen fuel cell, or whether it's going to be, lithium ion with two other things, we don't know yet, right? So there are a few things that are being worked on. And I think that even historically, you gave some good examples, Pavanji. And, one of my mentors used to tell me back in the day when there was this, GSM CDMA war going across in telecom, and, we didn't know which one will win. And, of course, there has sort of been a clear winner in that direction. I think that it's not that volatile or drastic when it comes to chemistries at the moment. But there is definitely going to be maybe a top 2 or top 3, and expecting there to be nine technologies working in some sort of hybrid structure might be challenging. And when I say that, it's also sort of keep in mind that these are cycles, right? These are sort of layered on top of each other. So it's just a matter of time. Once you invent something new, there is a cycle of validation, and then commercial approval, and then scaling, which sort of comes into play, and then the old technology becomes old. So I'm certain that lithium ion will be looked back at like lead acid and be like, wo lithium, lithium ion guys used to make those batteries at some point, and there will be a much better technology ahead, and it's going to happen much faster than what has happened with lead acid. So that is clear, right? It's going to happen. But it's also important to acknowledge that these changes are not always because of technology, but also because of a lot of governance and investments, like you mentioned, that take place, right? So many big companies have invested billions of dollars into building gigafactories for lithium ion. Tomorrow, if we have a new technology that is proven to be better, like literally, even if we know that it is better and cheaper, it's just going to take a decade to get it to a point where it's at a scale where you can really look eye to eye and say lithium ion is old news. But that's also the reason why especially the work that Log9 is doing, that Akshay and so many other companies that I know are doing on electrochemistry is super important, because there are issues with lithium ion. So it's not a cure-all. There are definitely opportunities to increase range, to improve charging, to improve safety. And we need to push the boundaries of what's possible with battery chemistry. What I can plug in some of the work that Ion does is that no matter which chemistry you'll end up using, hopefully you'll choose to use a smart battery management system, and that's sort of where we'll fit in. And no matter what chemistry you're using, you definitely need to get fueled up, and you'll find the infrastructure out there. So it's very beautiful that we have 3 very different types of people on the call as panelists today, and they, like, all 3 of us tie in very beautifully and seamlessly in sort of the journey ahead.
Absolutely.
Just wanted to make one very important point and build on what Akhil was saying here. So no matter what advancement happens, and actually as advancement will happen in chemistry, the requirement for a better BMS or a better software will only keep on increasing. Because as you will have more sophisticated technologies, you will need more sophisticated management systems, and then more sophisticated charging networks to charge them. So that's going to be the future.
Absolutely. In fact, both of you have said something which I also feel very strongly, that whoever is winning seems invincible. So if lithium is winning, it will seem invincible. However, that may not be the case. Reality doesn't endorse that, which is why I brought the other side of the metric, other side of the argument, that this is what they are saying about lithium, and they are comparing silicon's current reign with lithium's reign. But I also feel that it will not be, as Akhil said, it will not be a hybrid of everything. It will be, as you also said, Akshay, it will be a hybrid of some of the things. If we look at the hybrid of everything, we have ammonia, synthetic fuels, hydrogen, methanol, adiabatic, compressed air, liquid energy storage, pumped hydro, flywheels, supercapacitors, latent heat, thermochemical, and so on. The list is hundreds of technologies are there. But you have very valuably homed in on three kinds of technologies in particularly batteries, which makes the situation manageable and which illuminates the path a little forward rather than leaving it very loose that anybody can be a front runner. In your first slide also, you said that the front runners will be decided on these metrics. So that's a beautiful contribution. And the other point which Akhil brought in, shared understanding is required. Shared understanding and roadmaps are required between policymakers, industry, regulators, and investors. Because if the investors will end up investing huge sums in a technology which is likely to be dethroned, it will not be dethroned for some time to come, because that investment itself will create a bulwark against its displacement when it is due. So, which is why investors also have to be illuminated through discussions like what my fellow panelists are doing, so that they understand that these are the areas to go in for long-term success. And so that we don't bet on the wrong horse and then flog it disproportionately. Great points. Coming to Maxson. Maxson, the first point which Akhil brought in was about fast chargers. Can you, starting with that, tell us what are the viable innovations which are coming in charging infrastructures? Maxson.
Sure. Right. Thanks for that question. And I'm going to draw on a couple of points where Akhil and Akshay made. Just, I really like the way it was structured. Is we are in a technology transition. We have to catch up with 100 years of what we give the fuel stations of the world to build up on petrol, diesel. And it's even in petrol and diesel cases, it has not been, it has been, hey, listen, we are going from 0 to a octane 98. It has been a transition. Right? And we have to allow the transition. And anyone who's in the business of electric vehicle believing that, hey, I have found out the right solution and now I'm going to bet my next 50 years on it is in a wrong space. It will require people like many of on the call to take some bets, get an incremental change, allow, and then the ecosystem will come together. And like rightly said, it is not going to be a hybrid of everything. It is going to be a hybrid of the selective few. Right? And in the same way, even in charging, I mean, the conundrum of what material is the conundrum of how fast you can charge in the charging ecosystem. Because I did talk about a simple slide earlier, but it has a lot of complexity hidden in. Is people want to kind of replace the way they fuel up their vehicles in the same way in the charging as well. There's a lot of talk about DC fast charging, and I'm looking for Dr. Akshay and Akhil, Dr. Akshay, to build up batteries which can kind of absorb the high C rates and the BMS systems to allow those and actually control the battery temperatures, etc., and the other parameters, so that the charging can be faster. But what is it? How am I looking at it right now? I think if that I were to answer is, right now we are at a point where DC, watch today in India, we call DC fast charger, which is a 15 kilowatt charger. For me, it's one of the slow chargers. I wrote an article in 2018 where I said that DC 001 is redundant on the day it was launched. And I took a lot of flack for it, but today it is proven. I mean, the things have moved. So what does the future look like? There is going to be transition. The voltage levels are going to improve as the battery materials, etc., are going to improve. But however, you will not be able to discount the basic principles of charging is conversion of electricity into electrochemical energy, and how fast you do it is what is going to make the difference. In DC chargers, we have moved on from 15 to 50, and now we're talking 150 and above. So where is the sweet spot? The sweet spot is when you can charge a vehicle in 15 minutes for a ride of 200 kilometers. That's the sweet spot, we think, because we also run a platform called as EVET. EVET for us stands for Electric Vehicle Enabled Transport. Because that 15 minutes is not too much for someone to just freshen up, etc., and not too short also that you are unduly putting extensive pressure on the entire EV ecosystem. and also for enabling the power systems to take care of it. So I think that's going to be the sweet spot when I would believe that, hey, this is when the DC fast charging is going to happen. But I just want to qualify all my statements on DC fast charging with one bigger statement. Globally, at any point in time, 70% of the charging does not happen on fast charging. It happens at homes. We call it destination and opportunity charging, which is where people charge at homes in the nights and at the offices or when they are parked. The only reason when people go for fast charging is when they're on the highways, and also it applies for commercial fleets. So how we look at it is, we are not saying this is one solution, like I think Akshay said, that it cannot be one solution for all. So even in EV charging, these various ecosystems are going to, specific to the use cases, have to be built up. And if you're not ready for it, then I think we are destined for building a wrong ecosystem. And I always keep on challenging people to start thinking of it that way. But EV charging, one is that. The second is wireless charging. I'm looking forward to it, to be honest. I believe that that could be a possible game changer. There are technical constraints around it. The platforms which are currently available, the Qi charging, Qi as in the Chinese Qi, those have technical challenges around distances, dust, etc. But I think those are going to start changing the same way when we started off with a mobile phone. Of course, earlier it was wired, and now we also have wireless charging. But still, the standard wired AC charging may rule the roost for quite some time, till such time Akshay comes on with the entire differentiate. I mean, the concept of an aluminum battery system where you don't have to charge, you just the pre-charged aluminum material is just replaced. So you are actually replacing fuel from conducted energy to metal energy. I put it that way, Akshay, with your permission, and to oversimplify. So wireless charging is the next something to look out, that I believe. And second, there is another concept in swapping. This is $1 million question, swapping versus charging. My simple answer to that is, again, it is not a hybrid of everything, but it's a hybrid of something. Swapping does have a mandate for, there is a use cases for swapping as well. It continues to grow. It will continue to exist. So these, like there is petrol and diesel, there is going to be charging and swapping. So this is how things are going to work. But my bets are on wireless charging. As and when that happens, I think I would believe a lot of things are going to get simplified. That's my take on what's happening in the EV charging space.
Great, superb points. And we have discussed innovations in charging infrastructure, BMS, as well as batteries. Now I would like to come to the questions, because they are also reflecting very high quality of thirst for knowledge, as well as quality of information, which is already there, which is evident from the questions asked. And plus they are focused on the topic. So I will read out the questions and then go to you one by one. We will bunch, for want of time, we will bunch these questions for Akhil, for Maxson, and for Akshay. Maxson has already replied a couple of questions. The question which I'll come to you, Maxson, is about, what do you think about standardization of physical dimension of battery for the swapping technology? I'll just come to you. You have touched it, but I'll come to you this in a moment. I will begin with Akshay and close with Akhil. So Akhil, the questions which we have for you: how about the storage and scrapping of batteries? What are your comments on that? Then, do you use any machine learning model for detecting malfunctioning of the battery? This is the second question. For Akshay, the questions are, which is the best battery chemistry for light commercial vehicles? And what is the cost infrastructure required for aluminum fuel cell air battery? And have you participated in the PLI? And what is your experience and guidance? So these are the questions for you, Akshay. Let us start with your questions. Then we go to Maxson's and then to Akhil's.
Sure.
Akshay.
So first question first, that for light commercial vehicles, what makes sense? And I put 3 vehicle platforms in that category, which is starts from your two-wheeler for last mile deliveries, three-wheeler cargo passenger, and then four-wheeler LCVs typically plying intracity. So those are the kind of platform that we can look at when you talk about LCV. And for that, Log9 has already launched rapid charging battery packs in the market, wherein we are already offering max in 15 minutes up to 100 kilometers. Hopefully, we'll also be able to go to 200 kilometers pretty soon. So that is something which is available in the market, and that kind of takes away actually the need why swapping was introduced in the first place, because you don't need to wait for a couple of hours to get your vehicle charged, and within 15 minutes time, you are able to kind of fill your full tank, if I may call it, and then go back on the road. So we believe that this kind of rapid charging technology or battery packs will win the case, at least in this LCV segment, because it not only solves the downtime problem of the fleet operations, but it also solves for at the same time performance, because while these batteries can be charged very quickly, they can also be discharged very quickly. So hence you can get much higher power. And the benefit, another additional benefit, is that we get very long life. So the batteries that we have are already been validated and tested for more than 15,000 cycles, which is as compared to 1,000 to 2,000 cycles in the normal lithium-ion case. So that's what we've already launched in the market. Various pilots have successfully been completed. More are on the way, and the commercial rollout is due for October this year itself. So that is on the LCV side. Coming to aluminum fuel cell, as I mentioned, and I keep on drilling that message through in whenever I'm speaking, is that fuel cells make sense for long haul mobility. And the reason I'm re-stressing on this is because I keep on receiving requests from people, hey, can we get your fuel cell and put it in a two-wheeler? Fuel cell technologies are not meant for short haul and small vehicles. These are meant for long range, heavier vehicles, and that's where they should be applied, because that's where these technologies will make sense from an operational as well as cost perspective. And on that perspective, it is very easy to kind of go for aluminum fuel cell as compared to hydrogen, because in case of hydrogen, you require pressurized tanks, you need to have various safety protocols, and then production of hydrogen in itself is a very costly affair. Whereas for aluminium, we can use the same smelters which have been running for decades now. At the same time, storage is not an issue. You can store practically in a warehouse without any protective environment and carry it in a lorry, if I may call it. So from a storage, transportation, and replacement perspective, the supply chain becomes very, very simple. So that's on the AFC side. Yeah. Have I missed any question here, Pavan?
Yes, PLI. What has been your,
yes,
have you participated, experience, and advice?
Correct. So the PLI scheme is very important, and for the indigenization of battery technologies in the country. The only, so to say, point over here is that we have already kind of missed the bus in terms of setting up large-scale manufacturing in the country. Because while we are talking about PLI schemes of around 5 gigawatt hours and stuff like that, in India today, factories that are being set up across the world are in the range of 50 gigawatt hours and an order of magnitude higher. And competing with those kind of competing with that kind of scale will be a big challenge when you talk about the traditional and the conventional chemistries like LFP and MC. And that's the reason at Log9 we have taken a very conscious choice of looking at supplementary or complementary technologies which are far more advanced and new in that sense as compared to the conventional technologies. And what happens by doing that is that we are able to leverage the PLI scheme in the right fashion, and it removes the need to compete at such a large scale. So, for example, the kind of technology that we are dealing in, the largest facilities that exist in the world today are 100 to 200 megawatt hours. And that is something which you can easily set up, that you can at least find the right kind of investors to invest in and the right kind of scale to start with. And hence the technologies which is on the rapid charging side or on the aluminum fuel cell side, these are the kind of technologies where we will be leveraging the PLI scheme, actually the niche category of PLI scheme, which is a sub-segment of the PLI scheme, and hence set up smaller facilities to start with and still be able to compete on quality and cost, because these are new age technologies and new age for the entire world and not just for India.
Great. So niche PLI is viable, and you have already opted for it. That's great news. And you have also, frankly, in a truth-well-told manner, highlighted the areas where PLI requires improvement. But the fact that you are constructively participating in it also says that it has some good niche offers. Great point. I will be coming back to you because there are two more questions for you. But first I go to Maxson. And Maxson, what do you think about the standardization of physical dimensions of battery for swapping technology? Maxson.
Right. I think one of the constraints in swapping has been the standardization, and it's not only standardization of, I'll just first come to all the constraints and then talk about physical dimension. It's not only the physical dimension and hence the ability to swap, but also the connector. Very simple point. I mean, the connector has to be standardized. You can't have great simple 3x3 boxes, but the connectors being different. Third is the voltages by itself. I mean, you have different voltage systems running in different electric vehicles, right? So these are the three, I believe these are the three different standardization constraints that need to come through. And in that aspect, if I were to see, physical dimensions is one of the easiest ones to solve. Voltages being the most complex because you're talking about different species of vehicles, if I were to call, and trying to force fit a single battery systems. So this is where, but now having said that, in like what has happened is EV charging, there are these international protocols which have fallen in place. India has a great opportunity. I am a firm believer of that. Is unlike in swapping, globally, there are not many countries which have taken the swapping model, unlike China and Taiwan, etc. So India can actually drive the standardization of in the swapping space, be it the battery, be it the battery voltage system for two-wheeler, three-wheeler, four-wheeler, and elsewhere, the dimensions and also the socket points. For me, the bet is that given a year or two, I think that standardizations are going to fall in place. But this will require, again, what Akhil said earlier is about the fact that you need to be ready to accept change, if I were to put it that. And especially if someone has put up huge gigawatts, in this case, huge capacities of building vehicles with a certain voltage system, and now he has to undo that. These are going to be the constraints largely driven from the OEMs. And it will, I would say fleet-footed ones who have the ability to quickly skip it and change that are the ones who are going to drive that change in the battery swapping ecosystem. So that's my answer. Short and sweet is, not short and sweet really, but I kind of expanded it. Physical dimensions is going to be an outcome of the other two, which is the voltages and also the connectors.
Great points. So superb points.
There's also, there's also the notion of communication protocols, right? So even if you have your connector and, essentially even the physical dimensions in place, a battery is just a component of a system, right? And it needs to speak to the entire system and everything needs to work in unison. And so getting multiple OEMs on a single communication protocol inside of their systems is, historically been challenging. So just want to highlight that as well. It's not just the physical dimensions, but like Maxson mentioned, if we find some unique way of aligning Indian OEMs to align on these pieces, the reality is that India is one of the world's largest 2- and 3-wheeler sort of market, right? And with even alignment of 5 OEMs, for example, you could literally create a global standard. But it will definitely require a lot of, what should I say? A lot of people to give up ego and really sort of look at the bigger picture of the new energy transition, which is, it's admirable. Let's say that.
Great.
You've been trying to hold back some of the words that you wanted to kill. I would have gone all out on that, but yeah.
Okay, great. So last 2 questions from Akshay, and then we come to Akhil for any of his comments, as well as one more question, Akhil. And I'm sorry, I'm not taking the names of all the people who are asking these fine questions. They are almost all CXOs or managing directors, but they know that when I'm coming to their question. We would like to add to the storage and scrapping piece is battery afterlife and material recycling, Akhil. Before that, I go to Akshay. Will lead acid based batteries have a future? And which battery technology will lead in future among the lithium technologies? Iron phosphate or aluminium oxide or manganese oxide or air core batteries? Akshay.
So lead acid is going to be there for some time, at least a couple of years more, or I would say 5 to 10 year horizon, with purely winning on the dirt cheap cost of the battery packs itself. But in particularly talking about electric mobility, I don't think lead acid has any future in that perspective. And even the normal IC vehicles are now seeing a shift from lead acid to other kind of battery technologies for their starter battery packs. So from that perspective, lead acid is completely out of the automotive segment, but it will definitely stay in the stationary backup, power backup, and those kind of scenarios for some time to come. But eventually it will phase out in that segment as well, because as more cycle life and more reliability will start to play in from the lithium ion and the other advanced technologies that there are. Talking about lithium ion, I can't say which one would be a winner again in the different chemistry that there are, because that is something which remains to be seen. But what I wish for is what I can say is for technologies which are more environmentally friendly, because the entire ambit or the reason we're talking about this segment is to kind of save the environment, and hence some technologies are more environment friendly as compared to others, and low cobalt technologies will be the future in that perspective. So technologies which use lesser and lesser amount of cobalt, that those are the technologies we look at. At the same time, technologies which have higher and higher cycle life, and coincidentally, that is one and the same kind of technology. So technologies which have lower cobalt typically have better cycle life to offer, although these are not related things on an absolute basis, but that is how the market is right now. Because what happens is when you move away from cobalt, you reduce the emissions at the time of mining of materials. And when you go for longer life, the embodied emissions are there and serve you for a longer time on the vehicle side or on the storage side. So that's my hope, that these kind of technologies win the race.
Also, as far as mining is concerned, cobalt is a mineral which is associated, whose mining is associated with a lot of social, environmental, and other handicaps. Investors are also becoming skeptical of.
Also, if I may add on the recycling bit, recycling typically cobalt-rich chemistries is significantly more difficult as compared to non-cobalt chemistries. So that is another important piece to consider when we talk about end-to-end cycle life emissions of a system.
Great.
And I have a point to make, Dr. Pavan, with your permission, if I may.
Go ahead, please.
This is where from a technical perspective, Dr. Akshay did mention, but there's a fundamental usage concept that when you move the end of life of battery for a vehicle is not end of life of battery actually. There's only 50%. These batteries are, you call it end of life from a motive perspective, but remove the same battery from a vehicle, find the bad cells, remove it, and then it becomes a energy storage for stationary purposes. And that's exactly, and this is how one is not only about recycling, it is also extending the life and then recycling. I think that is the concept. And just, I'm going to connect with the panelists as well, is we're looking at that option of where this entire ecosystem is not only about building new things, is also extending the life and creating using the same batteries. I think this is one point which can be considered, and it's a big business case going ahead as well.
It's a beautiful point, because this is the point which Akhil also highlighted. It takes on from there, that the investors of adjacent sectors like energy or renewable energy, etc., also should together build this ecosystem, because part of what has been used here and is no longer that productive can be used in the adjacent sector of energy storage for stationary purposes. Excellent point. Coming finally to Akhil. So Akhil, your points about storage and scrapping of batteries, including battery afterlife and material recycling, and your points on, do you have any machine learning models for detecting malfunctioning of the battery?
I'm happy we got to this. I can speak a lot more time about machine learning because that's primarily my background. Like, I basically spent 10 years in machine learning and eventually found myself inside of batteries. So I can tell you a lot about how software can be leveraged to accelerate the Earth's transition to an all-electric future, which is also our mission. In the context of machine learning for malfunctioning, absolutely. This is the 101 that we can do for batteries, meaning we have algorithms running on our cloud for things like anomaly detection, early fault detection, predictive maintenance, and so on. So let me give you an example, right? Just to make a point, I'll give you a slightly exaggerated example, right? So imagine a large grid scale battery, right? So a large battery pack connected to a big solar farm that is balancing the grid, right? So when there's a lot of power being generated because the sun is out, you have excess of supply, less demand, right? And so you are filling up your battery. And when you have excess of demand and less supply, you sort of use the power from the battery to supply, right? If you imagine, like, we, even today on our platform, we manage batteries as big as, just to give you a sort of example, like 500 megawatt hours, single site. Okay, it's like a 10-floor building, okay, of a single battery pack. These batteries have over 300,000 sensors that are streaming data 5 times every second. Okay, so 5 times every second, you have 300,000 sensor data coming through. It's literally impossible for any human to be able to process any anomalous data that might be coming from these sensors. So one of the machine learning algorithms that we've deployed allows us to identify anomalies in the data coming from these 300,000 sensors, to be able to identify faulty sensors before they essentially lead to any fatal incident. And if you imagine, like, at a certain scale, imagine if you're Ola, hypothetically, right? Everything just becomes numbers, because you're operating in such high volumes that you don't really know that vehicle and that asset. When Maxson has 2 million chargers all over the world, like, everything is just numbers, right? It's not really that charger in Gurgaon. And so what happens is when things start working at scale, machine learning really starts kicking in, because you can then start identifying patterns. You can start identifying early faults and be able to prevent downtime, not only for your assets, but also for your customers and eventually the users. So are we using machine learning for malfunctioning of batteries? 100%. We have multiple neural networks that are running both in the cloud as well as on the edge, but not only to prevent malfunctioning of batteries, but remember, like I always say, a battery is just a component of a system. Like, it's the battery itself is just sort of the energy source in that sort of environment to deliver some function. It could be to move a person or things from point A to point B. It could be ensuring the grid is up and running. It could be your phone is charged. It could be anything, right? So when it comes to machine learning, it's not just about preventing malfunctioning of batteries, but really how to extend the life and performance, like we spoke about earlier, of these systems. Like we discussed before, the future that we're going to live in, electric vehicles will outlive multiple battery replacements, right? And so if you can extend the life and performance of these batteries, you're effectively going to lower the total cost of ownership and enable shared utilization of assets. And that's essentially the future that we're headed towards. So a lot of software being used by our customers. Today we're managing close to 1 gigawatt hour of batteries in the cloud. And it's really nice to see how software makes its way into being able to have a significant impact on the new energy transition. I don't want to speak a lot about the recycling of batteries. It's not necessarily a space that I have a lot of exposure to. I think Akshay probably has more exposure there. My 2 cents are very much in line with Maxson, meaning that the reality today is that if you do a good job of state estimation and management of the battery, you can reuse it for multiple applications. And while for mobility, the demands are, high power, high density, and you need to be able to pack it inside of a vehicle that can go from point A to point B. When it moves into stationary, it's slightly more relaxed, meaning that you have some more space available. You can put in more batteries, and you can also accept an end of life that is deeper than 80% or 70%, which is what mobility typically appreciates. So you can have an extended long term. In fact, I know third life application companies that are sort of going even sort of to the last fag end. And an interesting aspect, just trying to combine these two questions, if I may, is one of the offerings that we recently launched is second life valuation of batteries, right? So if you imagine buying a used car in the market today, you'll go and see how many kilometers it's driven. You look at the condition and try and make a market assessment, right, of what this costs. But when it comes to electric vehicles in the used car market, it's not so much how many kilometers it has driven, but how it was driven, right? Was it always fast charged? Was it always driven in ludicrous sport mode, like absolutely gunning for it? How was the battery used? Because you might have the same 10,000 kilometers driven, but the battery's health might be completely different compared to someone else with 10,000 kilometers driven. And because the battery is the most significant cost element of that vehicle, being able to value it means getting an assessment of the current state of health. And so this is again where software and machine learning can play a role to sort of look at the historical usage and try and value that asset by giving you a forecast of how many kilometers can this battery survive given the same usage patterns or differentiated usage patterns in the future. So a big believer in reuse of batteries across applications, not a lot of exposure on recycling, unfortunately. And like a massive believer of leveraging software to accelerate the Earth's transition to an all-electric future.
Super. So basically you're saying energy systems are becoming like large-scale software systems with thousands of communication sensors. This is an important part of the energy system, including the battery. Great points. And the other point which you have said is you believe more in reusing rather than disposing. Another great point. There are more questions, but I would have to now stop here because we have already taken 22 minutes more than what we committed. The quality of the dialogue is proven by the number of people we still have on the platform, and also by the questions which are coming in. Plus, several compliments are also coming in, not only here, but also on my WhatsApp. So please do look at the panelists. Will be happy to see how the audience has enjoyed your very well-informed session. And for balanced questions, I request Siddharth to handle them on the app. Also, Siddharth, there is somebody who has spoken very eloquently, but they are not getting the invite code. So consider that note as also a compliment, but make sure that they get the invite code for the app. And great points. And please do put up those slides which Akshay and Maxson have showed after their permission on the app, so that hundreds of more such inquisitive and well-informed minds can also benefit through that advanced learning. Great. Thank you very much, panelists. It was an interesting session also. I remember I chuckled on some of the points which you made, including what you said, Akshay, that bus can only carry the battery. It cannot carry any passengers because the load is taken by the battery. Okay. So great points. Siddharth.
Thank you very much. It's been such a privilege and a pleasure to hear you. Such an insightful and engaging conversation, and very well moderated, Mr. Choudary. Our leaders and I have taken home so much from today's conversation. I'm still receiving messages from leaders on my mail as well as on WhatsApp, and I really wish we had more time. And thank you to our leaders in the audience for joining in large numbers and for always staying till the end and for sharing excellent questions. For the questions that have not been addressed due to paucity of time, I will share the relevant ones with the leaders on the panel and request some of their time for it. And we will also try to share these questions and answers in the community app as well. and also take the slides from Dr. Akshay with his permission and post it on the app. Along with our weekly webinars and our publication, we're taking these discussions and conversations on the app across our 6 sectors, which are e-mobility, logistics, healthcare, energy, real estate, and aerospace and defense. So whether you would like to engage with us on the platform, readers are invited to connect with us, to join the mobility circle, as also get access to the other allied communities we're building. I've shared the app link in the chat box and will be emailing the leaders in the audience. Just one thing to note, that we've not sent the invitation code to the recent members or the ones who are interested, because we're launching a new version very shortly with new features added. So we would like to have you on board very soon, early next week or so. So thank you very much once again. It's been an absolute privilege and a big learning, and we look forward to having more such discussions in the future. Please stay safe.
Thank you.
Thanks, guys. Take care.